We didn't do this yet, did we?
Why? Oh, he did. I think mine if you practice, I'm looking at this.
Yesterday we talked about a whole lot of different theories that old Earth geologists try to come up with to explain what they observe. Today we're going to talk about how they basically force the evidence to fit their theories. Because notice the wording that was chosen. Technically, when you see evidence, what should you do with it?
Obtain it.
Something.
Burn
it.
Analyze it.
Analyze it and get what from it?
Yeah.
Scientific method, guys. You draw.
I diagnosed it.
No. Never mind that scientific method was chapter 1.
Yeah, it's still on it.
Technically, when we see scientific data and observations, what we should be doing is drawing conclusions from it, not making the evidence fit what we want to be true. Now, I will be honest, both sides do that a bit. But let's talk about theirs. First, we're going to talk about some of the problems they have with their theory of the formation of the solar system. You looked zoned out, that's what. First of all, we talked about this. Our solar system would have needed a supernova or something similar to create the kind of gravity that we see. But just like you guys asked, if we needed a star to make a star, where did the first star come from?
Big boom boom.
Well, that's the thing. Remember how I said they just like to push the problem further back? There are secular scientists today who basically their idea of how life got to be on Earth is that it came from an alien planet.
Right.
Okay, alien just means foreign, not Earth.
Thank you, Mrs. Stanley. You need to say alien. Russian. If he's all
Okay. Yeah, there are scientists who basically, when you ask them, okay, where did life on Earth come from? They'll say some far off planet somewhere else in the universe. Well, where did life on that planet come from? From another distance. Okay. And it's just this constant cycle. Another problem is that most exoplanets, and when I say exoplanet, I just mean outside of our solar system. You guys know that exo means outside. Now, some of those exoplanets are part of their own solar system with their own star. And they have properties that are inconsistent with the nebular hypothesis. Do you remember from yesterday, look in your notes if you don't, what were the predictions that the nebular hypothesis said we would see if it were true? No, predictions. What was one of them, Elijah?
The
No, predictions. Everything would spin the same direction. What else?
clumps of dust put together.
Look to the section of your notes that says the nebular hypothesis would predicts that the rocky planets would be closer to the star and what would be further out? Gas planets. And wasn't there one more prediction? Oh, the rocky planets would have a dense core. We can see within our own solar system that not everything spins the same direction. And this is saying some of the planets that we have found, turn around.
Noises.
Worried about you. Some of the exoplanets that we have found breaks one of those predictions, at least one, just like Venus and Uranus do. Stop. Now, so those, we talked first about the nebular hypothesis and how they think that started our solar system and how it came to form our Earth and all that. Now we move on to the second topic that we talked about, which is the geologic column.
That was like Monday.
No, this was like yesterday. Yeah, what?
The nebular.
Horses.
Monday was the geologic.
We haven't. But for you.
It
Okay.
does.
Anyway, problems with the geologic column. You remember that layer of rocks that I showed you with the supposed index fossils and all that? If it takes millions or even thousands or even hundreds or even a decade of years for a rock layer to form, then wouldn't there be weathering on the one below it?
No.
If you have something exposed for really any decent length of time, weathering happens. But we don't see that in the rock strata. No, there's no maybe. There is wind and water and, any sort of volcanic activity or earthquake, anything like that. So many. Okay, stop now.
What?
Everything you guys are doing to distract each other. That's what. We do not have evidence of any weathering between the layers of rock. We don't really have evidence of the geologic forces that routinely lift or tilt or fold rock. What could cause those three things? Earthquakes. What else?
What?
Sinkhole.
Well, that's more like a collapse. Meteors technically would cause some of that stuff. It'd cause some serious cracking, I'm sure. Volcanoes, things like that. But again, when you look at rock layers, and I should have brought up a picture, sorry. There are spots where you can find layers of rock that like a whole section looks like someone took it and turned it like this. But there's still all those rock strata. The entire piece was tilted, not just the one layer that had formed that took, and somehow it never got tilted in the thousands of years it took the next one to form. But what we do see are thick, undisturbed layers, super consistent with a large catastrophe. Like you've been trying to answer it for the last 2 minutes. The flood. Thank you. Okay. Another problem is the way they assign the dates. We talked. Oh no, I'm getting ahead of myself. Sorry. The assumption is that the atmosphere has never changed. But wait a second. What did they say the Earth's atmosphere was like to begin with? But wouldn't that affect the amount of time that it would take for those atoms to decay?
Sure.
But surely the atoms have always decayed at the exact same rate for all of history.
Yeah.
Because the atmosphere would not affect it.
Yeah.
You see the problem here, right? You sense my dripping sarcasm.
Yes.
I know that you sense my sarcasm there. You are fluent in sarcasm. Another issue, we talked a little bit about index fossils. Well, fossils require rapid burial. I'm going to pause right there. I know that there probably aren't as many There probably aren't very many nerds in this room. I am a nerd. Hey, what?
You said, I bet there are many, and I was like,
Yeah, nerd. It. That weird kid that I was that weird kid that loved dinosaurs when I was in second grade. I swore I was going to be a paleontologist, and I could even spell it correctly. And so I read all those books that talked about dinosaurs and how fossils were formed. Is anyone willing to admit that they did too? Okay. Okay. Do any of you remember what those books said about how fossils were formed? I can literally picture in my mind a sequence of pictures in one of those books. Am I the art teacher? No, I wish. See, at least yours was a little more accurate than mine, because when I was reading those books, they would talk about how the dinosaur is feeling sick or something like that and is going up to the watering hole to drink, and it dies. And it falls into the water, and it is buried by the sediments in the water until the sediments completely cover it. And over time, the sediments turn to rock and end up fossilizing the bones. And I'm sitting here going, even as a kid, what happens to a dead animal?
it decays.
It decays.
You were thinking about that as a second grader?
I was a nerd. I nerd. There is no was. I told you I wanted to be a paleontologist. I knew these things. I didn't say that was the fourth I could spell, but I can and I won't. So here's the thing that now they may have improved the theory since then. But number one, if an animal falls into a river dead, it is either going to decompose or it's going to be eaten by the things in the water. And its bones are not going to land in this nice little pile at the bottom of the river that's going to show us what it looks like. Because between the decomposition and the animals eating it, the bones will be scattered. Second, like Hank said, wait, every dinosaur just happened to fall in a river when it died and get not quickly covered by sediment? Like, what happens when a cow dies in a field if you don't get it? Anyway, point being, fossilization requires rapid burial. And for years upon years, scientists have had no good explanation as to why we have so many fossils, because they can't explain this rapid burial. And then there are the areas, like, again, I know this, if you go to Utah, there are what we have, or what we call the dinosaur graveyards, where it is hundreds of dinosaur skeletons in a giant mishmash pile. Wow. Somehow these entire herds all ended up in the same place and died simultaneously. That can't possibly happen.
It was the only river.
Unless what? Thank you. Again, not hey, you just like purposefully. Yeah, imagine that. Giant currents of rushing water associated with some huge catastrophe of water that would throw hundreds of bodies into one place. All right, I saw a hand. No. What was it? Yeah. And what? I don't know. I know there are forests. All right. So second, moving on from the rapid burial point. Second, we found dinosaur fossils with soft tissue still intact. What do you mean by soft tissue? Meat. Meat, flesh. That works. We're talking like skin, muscles, even blood cells. Okay, time out. Does anyone know how many years ago the dinosaurs supposedly died? 65 million years. And skin can last 65 million years?
Yeah.
No.
It
can't.
lasts 6,000.
No. Well, depends on how it's buried. What? So
It's a pterodactyl.
no, it is not. That's Archaeopteryx. Archaeopteryx. It's only the most famous fossil in all. Again,
Never heard of it.
so you're learning. You're not the nerd that I am.
Well, okay. Famous?
That's one of the most famous fossils ever found. Yes. That's a fake.
Yeah, fake.
That's real. So another issue is their idea that simple fossils in lower strata would have been, of course, laid millions of years before by the simple organisms, with the more complex ones in the higher strata, but we don't see transitional forms. We talked about this at great length last year. Do you remember? Do you remember what we said about the Archaeopteryx?
Yeah, they said it was turned into a bird.
Huh?
They said it was turned into a bird.
It's scientists, when they found the Archaeopteryx, I don't know if you can see it from where you're sitting, but when they found the Archaeopteryx, they discovered that it had feathers. You can very, very clearly see them. You can see them coming off the tail too. They said it got buried quickly by great rushing waters.
It's an eagle.
Rivers carry sediment, don't they? We learned that. So they went, "Woo, we found the missing link between dinosaurs and dinosaurs eventually became birds." Now, funnily enough, since then, they've very, very quietly come to the conclusion, oh, it's just a now extinct form of a bird. But you still find the kids' books that talk about it as a missing link.
Can you explain? Like,
You should show us the
Right here is the spine, and its neck is curved backwards with its head right here. It's like arched backwards. Here's one wing. Here's the other. It's two legs coming off, and its tail.
Show us a picture.
They don't know what it looked like.
Well, it's because they have a little person.
Of course they do, but I don't have a picture up there. Sorry. Another problem is that as far as the number of fossils that we find tons and tons of invertebrate fossils. What are invertebrates? No spine. Okay, can you give me some examples?
Oh, bit.
No. Invertebrate, a worm. Thank you. Huh?
Ant.
No. Insect. Yes. They're like entire inside. It's not. Yeah, it's basically nothing but spines and ribs. Thanks. Okay. But we don't find very many mammals, and we find even fewer humans. Okay. We'll come back to that idea when we cover it with the young Earth story. Now, we talked about ice ages. That was yesterday, right? Okay. So there's some problems with the ice ages. Try to follow me here. I know this is a lot of info, but obviously to get a glacier, you need a lot of snow. Well, in order for you to have snowfall,
You need
you where does the snow fall from?
the sky.
What in the sky? Clouds. Thank you. In order for a cloud to form, you need
Moisture.
moisture.
No.
Well, you've learned the water cycle by this point. How does moisture get into the atmosphere?
Evaporation.
Through evaporation. When does evaporation happen quickly? It's if Earth cooled slowly, there wouldn't be enough moisture in the air to create the clouds to get the amount of snowfall that you would need. It had already evaporated. You needed it to be warm and then cool down pretty quickly. Again, we will come back to that. So then the big question becomes, how do they fix those problems? What do you think they do?
They make up stories. They go back and back and back, and they can't.
Well, there's a few things they do.
They have their stories.
Stop. There's a few things that they do. First of all, okay, stop. Don't put it away yet. I want you to listen. First of all, and I told you guys this yesterday, and I believe the day before as well. Don't put it away yet. I want you to listen. Just stop and listen for a minute. I told you guys this yesterday. Geologists tend to think the answer to everything is to add more time. Because if you add more time in anything, oh, but see that goes against their model. And we'll talk about that some more tomorrow. Stop. Another thing they do is they just ignore it completely. If they do acknowledge it, they acknowledge it very, very quietly. So yes, they tend to be okay with fixing their models as they get new information, but the theory tends to not change, meaning they live with evidence that contradicts the story. Perfect example of this is a dinosaur called Brontosaurus. Have you ever heard of it?
Yeah.
It was one of the long-necked dinosaurs. What? What would you quit? Quit my whole story. Here's what? Not yet.
You told us there's not a lot.
Well, for those who didn't hear it, basically, what happened is with the Brontosaurus, the people who said, "Oh, we found this new dinosaur species." Well, what they found was a body over here in a different layer of rock strata than a head they found over here. We're talking like 50 miles apart, too, in different rock
Was that
strata.
tall?
According to their theories, oh, it's the missing head to the one we found over here. And they stuck it on there. Several years later, they found more specimens of those two dinosaurs and determined that they were two different sauropods. They had simply taken the body of one and the head of another, and they'd shoved them together thinking they were the same one. But you still find kids' books with Brontosaurus in them.
So are there
They're good
long-necked
guys.
dinosaurs?
Brontosaurus did not exist.
What about the long-necked dinosaurs?
Oh, there's lots. There's Brachiosaurus, Apatosaurus, Diplodocus, Supersaurus.
I have a question. Why
I
are they
know.
having that? Why did they name it?
They give you a pen that doesn't work very well. Or you just have to be smarter than the pen. What? Okay, stop. That's going to get recorded. Stop. Y'all need to stop with the paper before I have to call Mr. Zamora down here again. And I guarantee you that he would be super unhappy.
What's that?
What? Brush your head off right now. Because apparently when Mr. Zamora says keep your hands off each other, you seem to think you're going to do something else instead. All right, now listen. Listen. My goal is to not assign any of the worksheets from this chapter because they're all like short answer stuff where you have to write out 2 or 3 sentences to explain. Right? Now, you have 10 minutes of class. You can work on vocab, you can work on homework, you can just basically not be completely chaotic so that I don't feel like I have to punish you with homework, right? I'd rather not.